This episode of Serverless Chats is sponsored by IBM Cloud, the most open and secure public cloud for business. This week, I chat with Michael Behrendt about serverless at IBM. This is Serverless Chats, episode number 85. Hi, everyone. I'm Jeremy Daly, and this is Serverless Chats. Today, I'm speaking with Michael Behrendt. Hey, Michael, thanks for joining me.
Hey, Jeremy. Thanks for having me.
So you are a distinguished engineer, chief architect, serverless, IBM Cloud at IBM. So why don't you tell the listeners a little bit about your background and what you do at IBM?
Sure. Thank you. So I've been working at IBM in various technical roles over the last 15 to 20 years, have been in product development, product incubation, have been working in the field as a worldwide architect. And for the last 10 years or so, I've been working in the cloud division in itself, working on various topics, incubating it and so on. And since about 6 years now, I'm really focused on serverless as a topic as a whole. So that's what I'm doing for most of my time, working with customers, working on product development, making architectural decisions, technology decisions, and so on.
Awesome. All right. Well, so first of all, I want to thank IBM for sponsoring this episode. So that's great, continuing to support the community and continuing to invest in serverless. And when it comes to serverless at IBM, you are like the guy. Like you were there like right back in the beginning. I had Roderick Rabba on the show a couple of weeks ago, and we were talking about how it all got started. But I know you have a bunch of stories as well. So what if we go all the way back and start, that sort of 6 years ago, and talk about like how did it begin? How did serverless at IBM sort of get kicked off?
There are some interesting stories there. So a long while ago now, I've been looking into the serverless market as it was evolving, what was happening in the field, like what customers are doing, and I felt like we need to do something in the serverless space as well. And by purpose, I thought we shouldn't be starting this as a right off the bat product development effort, but rather, since it was such a new space, do some exploratory stuff first and have it really open-ended in terms of what we're going to end up with from a technology perspective. So I was in Beijing for a business trip, and I had a call with the VP for research at IBM for cloud. And I still remember it was like 10 p.m. at night, and we talked about like we need to do something in that space. So we agreed on that call, let's do something in that space. And he basically then brought in a team from the research side. Roderick was part of the team to kick off that whole effort.
Right. So I don't think I've ever heard a story that starts 10 p.m. In Beijing. Ever heard a story that didn't end or didn't have an exciting ending to it. So all right. So you brought in this team to kind of start working on it. And so what was what did you do first? Like what was the initial goal? I mean, you were surveying the market, doing the research, as you said. So sort of how did you sort of take those first steps?
So we put together this team of really talented people in research, and we basically set up our goals. Like what do we want to accomplish from a workload perspective? Which kind of workloads do we want to support? We want to allow composition of functions, something we are talking about these days as well, but it was like a new concept back then. We wanted to be able to be very flexible in terms of which kind of workloads people can run. Should it only be functions, or should it be more cost-granular workloads as well? So we went into different directions. We looked at non-functionals, like how quickly should it be possible to deploy a new function or update a function to have a very quick inner-loop development cycle. And that drove lots of technology and design decisions. And we've been running that with playbacks every week, I believe, where the team played back to a broader group of people, like what they were doing, their findings, and so on. And then we iterated our way towards into that. And one of the big milestones that was at the end of this first wave was OpenWhisk as an open source project.
Right. Right. So, what were some of those early use cases? Because that was one of the things where, when serverless sort of first started coming out, and again, OpenWhisk is a fast, functions as a service, similar to Lambda or Google Cloud Functions, things like that. But what were those early use cases? Because I remember way back in the beginning, it was very, very limited.
Yeah, yeah. So I think one of the first use cases was like, and that is a bread and butter use case these days as well. Still, it's those HTTP endpoints.
Mm,
That was a very broadly applicable, horizontal, in many industries applicable use case. Another one that still I still remember the, specific customers we were working with in these days was data processing, like
mm,
objects or photos in particular that had to be processed in a certain way, like auto cropping, auto sharpening, object detection, storing metadata. And I still remember we had one of our very first customers, like they went GA while we were still in beta. And so because like they felt good with what they had. And I still remember talking to the CEO one time, and he said in the early days, like their operations guy talked to him and asked like whether our billing engine was broken because the bill was so low.
right.
And they came in from a PaaS background, so they moved from a PaaS to a function as a service, and what they saw was like 10x performance increase in combination with 90% cost reduction. And that was just astonishing to them, which they had never seen before.
Right. Oh, that's amazing. So, so we can't talk about functions as a service without sort of talking about the 800-pound gorilla in the room, which is AWS Lambda. But I know that, and this is something I actually really appreciate about what's happening in the serverless movement right now, is that people are looking at it slightly differently. So while everyone's trying to come up with a definition, sort of how people are applying it and how they're looking at it, there's a lot of diversity there. Whether it runs on Kubernetes or whether it runs on its own VMs or whatever it is, or the V8 engine if there's something like Cloudflare workers. So there's a lot of I guess, difference of opinion, but in a good way. So I'm curious, looking at something like AWS Lambda, which I know, talking to Roderick, that sort of triggered like, hey, we need to do something as well. Just what's the different philosophy there, I guess?
Yeah, so I've been talking to many customers over the last years, and many of them are using serverless, but many of them are still not using serverless yet. And one of the biggest inhibitors I heard frequently was like, we would love to use serverless, but you are too constrained in terms of memory. You're too constrained in terms of CPU. You're too constrained in terms of execution duration. You're too constrained in terms of your programming model, JSON in, JSON out. You're too constrained in terms of XYZ. So while people love the attributes of serverless, they do not always like the constraints that come with it. And the
Right.
attributes are, I think, what is dominating these days the conversation in terms of I don't need to manage infrastructure. I only care about my code artifact. I never pay for idle. I I only pay for what I consume versus what I allocate. And those are foundational attributes of serverless that in my world define today what serverless is, and they can be applied to a much broader spectrum of workloads than just what you can handle with functions only.
Right. Yeah. And it's sort of an interesting balance because for me, I really like some of the constraints of serverless. Like I like that it's event driven, you know what I mean? I like that, they don't run for, 10 hours or something like that, that you have some of that, some of those constraints that almost force you to think differently about building your application. But on the other hand, I can see why, certain customers would say, if we wanted to move to this as a primary compute model, that we would have to have different ways that we could overcome some of these sort of artificial limitations.
Yeah, yeah, and sometimes it's a performance thing. Like if you can get more processors within the same process space, they can do they can do data sharing within that. Or some of the one of the constraints that has been imposed a lot in the early days of serverless was like there was no node-to-node communication possible.
Right.
So it was very hard to build up anything that had like latency sensitive communication required between the nodes of that distributed deployment. So I, I think there is lots of goodness in terms of trying to stick as closely as possible to the constraints that were kind of established as part of the almost manifesto of serverless as it was established, but still have the freedom to go beyond that if you want to do that.
Right. Yeah. And I think that's interesting to say, like, if you need 100 cores when it spins up on a function for 2 seconds or something like that, that would be that'd be interesting to have. So let's talk about that. So let's talk about some of these other applications that IBM is looking at trying to expand serverless into. Like, what are some of these other application types?
Yeah. So what we are seeing a lot these days is, like I mentioned before, data processing, but not only data processing in a necessarily embarrassingly parallel way, but also data processing that requires some more tight coupling between the processing entities. If you just want to do a group by or a join or something that just requires more data sharing between those components, that's something we are seeing. And then all sorts of workloads, like I said, that go up in the high double digits of gigabytes of memory, or that require longer execution times. Lots of stuff in the AI and ML space,
Right.
both in terms of serving, but also in terms of training. I think everything around data in the broadest possible sense, be it data pre-processing, be it data analytics, or be it AI/ML, is something that we are seeing a big uptake on.
Right. Now, what about some of the customers that are using this now? So, like, what are you seeing them doing with sort of the expanded capabilities that IBM has?
Um, I see there are some low-hanging fruits for people to get into the serverless space, and what I think is important as well is to like from a customer value proposition, when I talk a lot to large enterprise customers, from a customer value proposition, there is value in running like a dozen HTTP endpoints on a serverless platform, but that only consumes up so much capacity, right? An
Right.
HTTP endpoint is usually not overly huge in terms of its resource footprint. But when you think about like data processing or data analytics workloads, they can be really big. And so what I see customers are starting to do is looking at those workloads. Also, batch, for example, is a typical case. Like and not batch in the necessarily traditional sense, where you have like a batch run start at midnight and it only processes then, but maybe continuous batch in the
Mm-hmm.
sense of I have like, since I'm serverless, it doesn't matter whether I spin it up all at midnight or always on demand at a point in time when I need it. And so from that perspective, customers are seeing value in taking forward those kinds of workloads to say, I can get it more real time, maybe almost close to interactive for certain use cases, where
Right.
in the past I had to wait for a few hours to get something done. Now I can sit in front of the screen and wait for it because I'm getting 1,000 cores instantaneously.
Yeah. Well, and that's one of the things that I really like about like an ETL task with serverless would be this idea of running things in parallel as well. So there's some cases where you can't just split a job up into parallel and hope it all finishes in 15 minutes with, I mean, now you can get 10 gigs with Lambda. But I mean, I certainly see there being a huge benefit to saying like, well, maybe a job has to run for 30 minutes. Maybe it needs, X number of cores or whatever it is, and being able to sort of parallelize that out. So is that something, though, that you're seeing where the mindset is, all right, we can use these serverless compute and scale them up really, really large and be able to do that? But are you still seeing people saying, well, if we split them into, if we parallelize them, we can do this much faster?
Absolutely. Like the rethinking of certain ways of doing data processing is a very interesting one. To give you one example, and it's quite popular specifically in these days. There is one customer, a European molecular biology laboratory, quite a mouthful of what the name is, but it's the interesting part is they are doing life sciences research basically. They are dealing with certain data that's taken out of the body,
Right.
how cells work, how the internals work, and they have large data sets, and they want to be able to process them. And the folks working at EMBL, they are not all of them are computer scientists. Many of them have a expertise in a different domain, but they use the computer science as a means to an end to do their job. And so what they started doing is they started to rethink how they analyze these metabolomics, it is called, those metabolomics data sets, how to break them down and process them in parallel with cloud functions on the IBM side instead of traditional ways. And that gives them both the benefit of it's much cheaper, it's way more cost effective, and they did a very detailed analysis about that. And at the same time, the folks working there get more productive because they get their results faster than they did before.
Yeah, that's amazing. And I love this idea of, again, just the parallelization of jobs that would normally take, like, I mean, thinking like Hadoop jobs or things like that would just take hours and hours to run, and then you'd wait and then say, oh, I think I didn't write the query correctly or something like that, and then you end up with junk data and you have to do it again. So no, that's amazing. So all right, so there's a whole bunch of customer examples I know that you have, and we can talk about some more of those, but I'd love to start talking about IBM Cloud Code Engine and what that is and how that helps people go serverless.
Sure. So when we made this observation that I described in terms of customers wanting to have the serverless value propositions, but have the ability to go beyond the constraints they were imposed on. We made it a few years ago. We started this effort, which is now in the market as IBM Cloud Code Engine. And it's basically our implementation of this mindset of, I call it Serverless 2.0, which is preserving the value propositions, but giving people the freedom of high amounts of CPU, memory, disk, long duration times, and so on. And we are focusing on initially, again, HTTP serving workloads, of course. We are focusing on batch workloads, and we offer people the ability to run their container, whatever it is, on our platform. So with that, it becomes a general purpose capability as well. And they don't have to make trade-offs. Like in some other places, you have to make a trade-off whether you want to have scale to zero and very fast scaling, or you want to have large amounts of capacity. What we are trying to do with Code Engine is to not force people to make trade-offs, but to say, I can have all of those value propositions in a combination I like, versus having to choose between one or two or three different offerings.
Right. Yeah, and so now with Code Engine, you can write code like you normally would with a serverless function if you wanted to, right? You could just upload a snippet of code. But you mentioned you could also load a container. So what does that give you? Do you get event-driven capabilities when you load your own container? Can you schedule them? Like what are your options there?
Yeah. So we are making a distinction in terms of what is the artifact you're providing to articulate your business logic versus what can you do with it. And we give people the ability to, like I said, to provide their container, package whatever they want to into it, and have that as the artifact that articulates their business logic. It can be a function. It can be like an HTTP serving app, like a Node Express app, or it can be a batch job as well. But irregardless of what they are choosing as the input artifact, in the backend, it's all treated in the same way. And all the capabilities in terms of scheduled execution, event-driven execution, scale to zero, node-to-node communication, all of those capabilities are available irregardless of what the input artifact is.
Right. And I don't have to set up like a Kubernetes cluster or anything like that, right? Like I just go and it's there for me.
Yeah, I mean, like the Kubernetes and serverless world, they've been in interesting discussions over the last years, and there are very opinionated people on both sides. Um, the way we are approaching it is to say, like, what do pe is there what do people want out there want to have? Like, what is there a market for people who want to have something like a Kubernetes cluster, but not the cost and the pain of operating it? Um, and so what they can do as well is they can use Code Engine as if it was a kube cluster, but without having to own the kube cluster.
Mm-hmm.
Like they get the kube API, they can deploy something on there, they can run something on there, they can use kubectl, get pods and see their pods and so on. They can do all of that, but they don't have to. So we give them an abstraction where they never have to get in touch with any of that if they choose to run batch jobs or web apps or functions. But if they want to, if they have the expertise, if they need it for problem determination purposes or whatever else, they can also drop down into that as well.
Which is crazy. So, all right. So then, in terms of like users going in and setting this up, so like from a pricing standpoint, this is all sort of on demand. Is it? It gives you those serverless qualities that you were talking about.
Yeah, it's all on demand. It's a granular pricing, like on a 100 millisecond granularity basis. The pricing is similar to all the other players in the market as well. So people can again run batch jobs, HTTP applications, functions, containers, but the pricing model is the same for all of them.
Right. So then in terms of some of the use cases, you mentioned, HTTP and batch jobs and some of that stuff. So what are people using it for now? Are they taking advantage of all those capabilities? Are you seeing them sort of breaking those barriers of what you might be, constrained with typical fast offerings?
Yeah. Like the EMBL case, for example, I mentioned before, is one of those use cases. Then we are working with some large enterprises who have workloads for forecasting, revenue forecasting, and things like that, which they had run so far in a traditional way, which they are now rethinking in terms of how to run it on a serverless platform. And containers, that's a very horizontally applicable, very general purpose kind of thing. So people are using that often as the kind of catch-all for everything they cannot get addressed elsewhere.
Right.
And then HTTP endpoints are really often used as well as a kind of entry-level thing, because also that is very horizontal. And then people are starting to specialize in terms of, they say, I have this, like I said, this revenue forecasting application. I use the batch capability, or I have this embarrassingly parallel executable that I want to have executed 100 times in parallel. For that, batch is also really super useful, because you just specify your command, like on the Linux command line, what you want to have executed. You specify as a parameter, do you want to have it executed 100 times or 1,000 times? And then you just fire it off and it does all the work for you. So it's that broad spectrum of capabilities they're using.
Right. And you're also, depending on, I guess, which artifact you use. So if you just upload a function, you're patching the operating system and you're doing all those upgrades and all the security things. What about if you're using a container? Is that something you as a deployment method, do you have to sort of patch some of those things if you're containing runtime in there, or how does that work?
Yeah, excellent question, and that is often missed as a subtle discussion point. Like if somebody wants to provide a container, that person makes a conscious choice of wanting to have control over what is being deployed. So he can do anything within the container, but with that also comes the obligation of them having to patch it if there is something to be patched. If somebody says, I don't want to have to patch my node runtime whenever there is a new CVE coming out, I just want to upload my app artifact. They upload the app artifact, and in that case, we know what the artifact is they want to take care of versus what we have to take care of.
Right.
And when a new CV comes out for a node runtime, we would be patching the runtime automatically under the cover for that customer.
Awesome. All right. So, what about integration? So, IBM Cloud has got a lot of different offerings. There's a lot of different things that it can do. But from a serverless perspective, what does the code engine, does that have like native integrations to some of the other services in IBM Cloud?
Yeah. So we have integrations in terms of event sources. As you would expect, the usual ones
Right.
like object storage, Kafka for data streaming, and things like that. But we also have specific optimizations built into it, like setting up a really well high-end performing communication between a compute node or a set of compute nodes and object storage can be painful. Like you need to know which signature you're using. Are you using V4 or V2, depending on how many threads you should be using? How should the operating system be configured? So for those parts, we have basically tested and optimized optimizations built into it. So if somebody wants to interact heavily with object storage, which is a super popular case, they can do that as well. What we also have is like, for example, some of the AI capabilities like Watson Assistant, where you can build your chatbots and your interactions, and sometimes you need custom logic. You can articulate the custom logic in Cloud Functions. There are integrations in both sides, both offerings calling us, but also us being able to call others.
Right. Now with the containers, you can probably use whatever runtime you want, right? If you wanted to run Node or something else, you could do that. But if you're using one of the predefined runtimes, what are some of the runtimes that are supported if I just want to upload code? Because I just want to upload code.
Yeah, so it's the usual suspects. It's like Node, it's Java, it's Python. Python being really popular, or increasing in popularity, and it's like all the other runtimes as well in various versions, like Java, for example, yeah.
Awesome. All right. So you're clearly breaking some of the maybe I don't know if I'd call them the cardinal rules of serverless, but you're sort of like pushing past what people are like. Well, these constraints were supposed to be here, and so you're pushing past that, which I think is amazing. And I've said for quite some time that Kubernetes is an amazing technology. All the things that run with it are great, but it's just too complex for most people to manage. And you're not going to get a small startup with 3 or 4 people, installing Kubernetes clusters and trying to do that. And so I always looked at Kubernetes as just like the open source that will eventually be productized by all the major clouds, so that you don't have to worry about it. And so, and this, I think Cloud Code Engine is sort of doing that here. But what's the future, right? Like how far are you going to push this? Because what serverless looks like in 5 years is anybody's guess. With longer runtimes, more memory, less constraints. We're talking about state now, and how much state can be stored, and whether or not you can do, again, node-to-node communication is something that's still relatively new. So where are we going with this? Like, what's IBM's view? And maybe you as being so, sort of intimately involved here, like, what's your view? Like, where is this going in the future?
That's one of my most interesting topics I'm working on these days as well. So from my perspective, like we talk about serverless, and if I had to project out like 5 years from now, we would probably be talking not about serverless, but I just have one server, and that server has the capacity I need, and it has in terms of CPU, memory, and so on. But I think so far we've been treating the cloud as a place to deploy web servers, app servers, and database servers, if you want to articulate it in very broad terms, right? We've been looking at the cloud as a collection of virtual machines and of different server technologies. We've not been looking at the cloud as like a computer in itself. Like, what if I treat the cloud as a platform, as a single computer, which feels like a simple computer from a CLI perspective, from a programming perspective, and I think that's where serverless will be going. We sometimes use this term serverless supercomputer, which
Right.
basically means is I can define a computer of any size that comes within seconds and goes within seconds, and it's fit for purpose. It's customized to exactly the job I want to have handled now. And if I need now for 15 seconds 1,000 cores to do something, I can get that. But
Right.
it feels like a computer that I get for 15 seconds that has 1,000 cores, and not like a collection of containers or VMs or something like that. So I think from a user perspective mentality point of view, I think that's where we will be seeing lots of trend towards, in combination with programming frameworks that address this on a higher level. Like in the Python space, there is interesting stuff happening, and in other places as well. But like I'm very much behind this thought of a serverless supercomputer, which lets us treat the cloud as a cloud computer and not as a collection of stuff.
Right. Yeah, no, I love that idea because I think about serverless, sort of the first iteration of it, which was upload a little snippet of code and it just runs, right? And I mean, then it got to be more confusing, or more, not confusing, but more complex, where you had to start saying, okay, well, I want this event source, I want that event source, and then, oh, there's some failure modes in here, and then, oh, wait, now I need to run things in parallel, and then maybe I need to run multiple jobs simultaneously, or I need to compose functions, which has always been, I guess a debate within the serverless community. Like, how do you compose functions? I know it's always, should functions be calling functions and things like that. And of course, there's been a lot of technology advancements that have made that easier. But what we're doing is we're just stitching together a lot of primitives, right? Like, we're saying this can do this can do that. But like, I just want, to run a snippet of code that can buffer events coming into it, but I have to set up a queue, and I have to set up the function. I have to do some of these other things. I have to worry about scaling. I have to worry about maybe, downstream throttling so that I don't overwhelm a downstream system. I mean, there's just so much to think about now when you're building distributed applications. So let's go back to the supercomputer for a second, though. So what's the vision? Like, how do you envision that working? Like, as a developer, I just want to use, like you said, 1,000 cores. What's that experience look like to you?
So the way I'm thinking about this is, like, we all know, and most of us love, the Linux command line.
Right.
Right? It's a command line. It has often been used as the poster child for good practice of how to develop capabilities, small chunks of functionality, you can stitch them together. So today you have a CP command, where you copy data from one machine to the other machine, or from one place on the disk to a different place on the disk. How would that CP command look like in a cloud? That CP command would look like in a cloud in a way where you enter CP, you copy data from A to B, but under the cover, maybe 1,000 cores get spun up, or
Mm-hmm.
150 gigabit interfaces get spun up instantaneously, and they all transfer data from one object storage to another, or from one device to another. They do the chunking of the data behind the scenes. So it's still just a CP command that you enter on the command line, where you have, like, within, just for a few seconds, maybe if it's only needed, like, enormous amounts of network bandwidth available, because it's handling all of that behind the scenes. You
Right.
have enormous amounts of compute available if you do not only have to copy the data, but you want to have an FFmpeg. Like, there could be a superpower FFmpeg version. There could be a superpower of pick your favorite executable or Linux command executable. And then if you do it that intelligently, you can also pipe them together. And that is just what I'm talking about. It's just the command line part of it. The same thought process can be applied to writing Python applications, or writing Java applications, or running batch jobs, or executing your favorite application. You can rethink all of them in a way of, what if I want to make this as usable as something running just on my laptop? but with superpowers behind the scenes.
Right. Yeah. No, I love that idea. I mean, one of the things I love about the supercomputer idea is just the cost of what that would be. I mean, you can kind of do it now, and you mentioned that example, with the research, that you can just sort of spin up all this stuff very quickly, do some big job, and then spin it all down and then not pay for it. Because I do think that would be really interesting, just in terms of what you could find out. What could somebody do from their garage if they had an idea and they wanted to run some sort of model and figure something out, rather than spending millions of dollars on virtual machines and paying for those, or even running serverless functions and having to figure out all that stuff. Just gets really confusing. So, I know there's sort of we're not quite at the supercomputer yet. Although I do think some people are starting to use that, or at least take advantage of that. So, do you have other customers that are doing interesting things by just doing this massive parallelization?
Yeah. There is one customer, I can't use the name, but it's a large enterprise that does revenue projection. So they always forecast for the next 30 days what is the revenue, and they've been running it so far, I think, once a day or so, because that's they couldn't execute it faster, so they needed that one day to
The whole
execute it,
day.
and then they had a weekly run. And I think so they moved this over to serverless, and it's now almost operating at interactive speed. And I think that is a big part of serverless. What a serverless is getting us now is, in general, like, I think the next big wave is making basically everything that was not interactive so far because of those user constraints interactive. Like, give people the ability to do large things, but not run them overnight, but do them right here, right now. And that unleashes another degree of productivity, because if you can turn around things, we all know that from our daily development, if your inner loop development is super fast, and you do a command S and refresh, and you run your code again and again, that unleashes enormous productivity. And if we can apply that to other domains as well, like data analytics, for example, I don't have to worry anymore about subsetting my data to a small chunk of data that I can test something on, and then I run it on the big data. But I can always run it on big data, because then I can be sure that I didn't choose the subset of data that's not representative for the bigger amount of data I want to execute on.
Right. Yeah. And I can see, again, I think people are already doing this with like CI/CD, just to build and deploy projects faster. They're like using serverless to deploy serverless. It's pretty fascinating. All right. So one more thing I want to talk to you about before I let you go. And so Cloud Code Engine, gives you all these capabilities. You can do all this stuff. How does that compare to just Cloud Functions, or are they the same thing?
Yeah, it's a good question. So Cloud Functions is really, from a technology perspective, the most competitive one in terms of cold start times, super rapid scaling from 0 to 1,000 in the shortest possible amount of time. There we have lots of optimization built in. Lots of optimization in terms of pre-warming machines, keeping them around for a longer period of time, caching them, and so on and so on. And so Code Engine implements that capability and addresses that segment of the market with Cloud Functions. And with Code Engine, we address this bigger space of the market where you have large capacities and all those constraints unleashed. We want to bring them together so people can use them in combination. So it's not one versus the other, but rather one complementing the other.
Right. Okay. So if I was starting out and I was just starting to build on IBM, would I go with Code Engine or would I go with Cloud Functions if I wasn't worried too much about the constraints to start? Let's say, what would
Yeah.
is Cloud are Cloud Functions like an easier just easier to work with? I mean, I'm sure it's all easy to work with, but like what would you suggest for a beginner moving over there?
For a beginner moving over there, I would probably start with Code Engine for the simple reason that it's applicable to a broader spectrum of applications.
Gotcha. Okay.
So there is a very wide spectrum of applications that they can serve with this. If they have requirements that make Cloud Functions really well suited in terms of they have high dependencies against low cold start times and things like that, then I would go for the Cloud Functions part. But I would suggest as the entry point, because it's much broader in terms of addressable workloads, I would suggest Code Engine.
Awesome. All right. Actually, I have another question for you because this I'm just I know we talked about a lot of customer examples, but I love hearing customer examples. I love hearing use cases. I love to know what people are doing with serverless because it always I always hear new ones and it just it opens my mind. So what's your you mentioned a couple of them. You talked a little bit about the the ETL ones and obviously the big data ones. But what's like your favorite? What's your favorite use case or customer example of people using serverless at IBM?
Oh, my favorite one. There are so many. I think the most recent one and most favorite one, because it fits into this day and age so well, is what the European Molecular Biology Laboratory is doing, because they are doing research. They're doing medical research. They are looking for new medicine, how they can cure certain diseases in a better way. And I think it just hits the world we're living in today so well. And we can help with technology to accelerate what they're doing. So that's why I think today I would be picking them, because they fit so nicely into the world we're living in.
Yeah. No, that's amazing. I've heard so many stories of people using various serverless products and databases and other things to do research on COVID-19 and all these other things, is just solving these problems, which I just don't think would be anywhere near as easy or as quick without this technology.
Yeah, exactly.
Awesome. All right. So listen, Michael, thank you so much for joining me and for the work that you're doing. Again, continuing to move the ball forward on serverless is not an easy task. So I really appreciate that you're on the front lines of that and moving that forward and thinking about it differently, right? That if everybody thinks about it the same way, we're going to just probably repeat the same patterns that we've done in the past. So thinking about it differently is amazing. So I appreciate that. I know others appreciate that. So if people want to get in touch with you and maybe ask you some questions, or they want to find out more about Code Engine and Cloud Functions, how do they do that?
So they can get in touch with me via Twitter. They can. I think you have the Twitter handle.
Yes, Michael_BEH, and I'll put that in the show notes, so you'll have it.
Excellent. And if they want to use Code Engine, they go to cloud.ibm.com/Code Engine, and there they can try it out. It's in beta. Watch this space. It will be evolving quickly. Looking forward to any kind of feedback people are having, and reach out to me on any of those topics we talked about. Like, I'm interested in what people out there are thinking, and we can maybe keep the dialogue going also asynchronously.
Right. Yeah. No, I mean, getting input from people, feedback is going to be super important as this whole thing grows. So, all right. So Twitter, I'll put your LinkedIn in the show notes as well. So I have ibm.biz/code engine or cloud.ibm.com/functions for Cloud Functions. We'll get that in the show notes. Michael, thanks again.
Thanks for having me. Really enjoyed it.
And that's this week's Serverless Chat. I want to give a huge thank you to Michael Behrendt for being my guest this week and to our sponsor, IBM Cloud. If you want to check out the show notes and a full transcript of this episode, you can find them at serverlesschats.com/85. For more Serverless Chats, subscribe, sign up to be an insider, check us out on YouTube, and follow us on Twitter, Facebook, and Instagram. You can connect with me on Twitter at Jeremy_Daily, and if you want to keep up to date on everything serverless, make sure you subscribe to the Off by None newsletter at offbynone.io. Thank you so much for joining me, and I look forward to chatting with all of you again next week.